In this video, we are going to discuss a very important resource in the nodes, that is system reserve. First, we will see what is system memory, why we need it, and how to configure it on the nodes. Stay tuned to get more information on the system reserve resources. Hey everyone, it's Kavin Mali here from GeekSurf, where I talked about technical stuff. If you are seeing value in this video, make sure you give it a thumbs up and click on subscribe button. Share this video with your friends. What is system reserve? System reserve is meant to capture resource reservation for operating system daemons like SSD, UDEV, etc. System reserve should reserve memory for the kernel too, since kernel memory is not counted for pods at this time. CPU memory thermal storage falls under the system reserve. Why do we need a system reserve on the nodes? It's easy and you already know it. First thing, to provide more reliable scheduling and minimize the resource overcommitment. Second point, by specifying the resources to reserve, we provide a scheduler with more information about the remaining CPU and memory resources that node has available for pods. Let's understand with an example. Here we have a node which has 32 GB of memory, 16 CPU and 100 GB of storage. If we set system reserve to memory 2 GB, CPU is 2 core and thermal storage equal to 2 GB, then scheduler ensures that the total memory request across all the pods on these nodes does not exceed 30 GB, as we already reserved 2 GB from it. Same with the CPU and storage. Scheduler make the CPU should not consume more than 14 CPUs and storage should not cross 98 GB. Now let's check how to configure system reserve on the nodes. There are two ways to configure it. First, automatically allocating resources for nodes. Second, manually allocating resources for nodes. To automatically determine and allocate the system reserved resources on nodes, create a kubelet config custom resources to set the autoSizingReserved true parameter. A script on each node calculates the optimal values for the respective reserved resources based on the installed CPU and memory capacity on each node. Automatically determining the optimal system reserve settings ensures that your cluster is running efficiently and prevents node failure due to resource starvation of system components such as cryo and kubelet, without your needing to manually calculate and update the values. This feature is disabled by default. To enable it, use the kubelet config file as mentioned in the previous slide. Now, let's check manually allocating resources for nodes. To configure resources manually, you need to add system reserved parameter in the kubelet config CR as mentioned here. Let's do a demo on automate allocating system resources. Here is kubelet config file. Here you can see that I have already configured the autoSizingReserved parameter set to true. Now let's create a kubelet config file. OC create -f YAML files kubelet autoSizingReserved.yaml. Okay, now you can see that kubelet config is already created. Let's check the kubelet config file. Let's see get kubelet config. Here you can see that kubelet config file is successfully created. Let me switch to the another window. Here you can see that I have executed watch on the nodes. Kubelet config enables automatic resource allocation on all worker nodes. Openshift container platform drains the nodes, applies the kubelet config, and restart the nodes. It will take some time. I will pause the video and will be back soon. Now you can see that all the nodes are in the ready state. Let's check the system reserve values configured on the nodes. For that, first log into the worker node. OC debug node and the node name. Okay. chroot/host. Let's check the kubelet process output. ps-ef grep kubelet. Okay. Here you can see that worker nodes are allocated with 0.07 of CPU and 1.6 GB of memory. Now let's move to manually allocating resources for nodes. Here in kubelet config file, you can see that I have already configured the system reserved parameter in the kubelet config section. Let's create the new kubelet config. OC create -x YAML kubelet manual resource allocation .yaml. Okay, it's now says that it's created. Now let's check the kubelet config. OC get kubelet config. Here you can see that resource manual allocation kubelet config is successfully created. Now OCP will apply the kubelet config and will restart the nodes. Here is the exercise. Now let me know in the comments how will you check if your system reserved config is applied to the nodes. Now nodes are configured with the reserved resources, but how will the nodes behave if there is a load on the nodes? To check this, watch my video, Openshift for container garbage collection with eviction soft and eviction hard. Link is already displayed on the screen and in the description. Thanks for watching my video and have a great day ahead.